Hello everyone, you're welcome to Medical Science Lecture Room. Here at the comfort of your living room, we try to teach you science and medicine. But today we'll be looking at a series of classes on mathematics, and the topic is trigonometry. Trigonometry is a branch of mathematics where specific functions are used to provide solutions to triangles. These triangles may be a equilateral triangle, a right angle triangle, and so on. But the most important thing is that once you're looking for a solution of a triangle, either you want to find the side of a triangle or you want to look for the angle of a triangle, you'll be thinking of trigonometry. Once again, the name is Dr. Godwin Obono. You're welcome to this channel. Please don't fail to subscribe. If you have any comment, drop them at the comment section. Don't equally fail to like the video or share. Let's begin. Trigonometry is a branch of mathematics that seeks to solve problems of triangles. Now, in doing that, there are specific functions that you must remember. We have what we call the sine function, the cosine function, the tangent. We also have the cosecant, the cotangent, the secant. So we have the cotangent, the secant, and the cosecant. Now, we also have the sine rule, the cosine rule. But for this are applied to right angle triangle. When you're dealing with right angle triangle, in other words, if you want to solve problems of a right angle triangle, you can either apply the sine, cosine, tangent, secant, but you do not apply sine rule and cosine rule to a right angle triangle. You apply sine rule or cosine rule to other triangles that do not have either of the angle 90 degrees. Remember that a right angle triangle is a triangle that has one of its angle to be 90 degrees. So when you have a right angle triangle and you want to find the side of a right angle triangle or the angle of a right angle triangle, then you'll be thinking of sine, cosine, tangent, cotangent, secant, cosecant, depending on the question. But if you're dealing with any triangle that is outside, any triangle that do not have one of its angle to be 90 degrees, then you'll be looking at sine rule or cosine rule. The question is that what is a right angle triangle? Now, if I take, for instance, you know that a triangle is a mathematical figure with three sides. Now, if I draw a straight line, for instance, and I decide that another line is drawn down such that this line meets this other line at an angle. Now, remember that this way, at this very point, this angle here is 180 degrees, and this other angle down here we 180 degrees. And of course, if you consider from here to here, it gives you a circle. That is why we say the angle at a point is equal to 360 degrees, because 180 this way, 180 this way gives you a total of 360. But when we look at the upper part of it, now this bisector must have divided this angle into two, such that here will be 90 and here will be 90. And so if I decide to draw another line here, I have gotten a triangle, because three lines are now bounded. This is the line, this one, this another, and this is the other line. So if I decide to name this angle A, B, and C, that means we have a right angle triangle ABC. It is right angle triangle because one of the angle is 90 degrees. So when you have a triangle like that, where one angle, remember, if there is an angle here, there is another angle here, and another here. An angle is formed when two lines meet. So if this line meets with this other one, you can have an angle here, let's say theta. If this line meets with this other one, you can have another angle, and let's say this angle is alpha. Whatever name you chose to call the angle doesn't matter, but know that there has to be three angles here. And if there are three angles here, it therefore means theta, which is this angle, plus alpha, which is this angle, plus 90. This is the only angle that is known. It's equal to 180 degrees. Now this again tells you that the theta plus the alpha is equal to 180 minus 90 degrees. You know very well that the sum of angles in a triangle must be 180. That's why I said theta plus alpha plus 90 is equal to 180. And when I have written it there, and I make what? Theta and alpha the sum of the formula. 90 goes to the other side. It becomes what? Theta plus alpha equal to 180 minus 90. And that will give you theta plus alpha equal to what? 90 degrees. Now, because theta and alpha has summed up to give us 90 degrees, we say therefore theta and alpha are what? Complementary angles. Complementary angles. Complementary angles are angles when added together. The two gives you what? 90 degrees. So when you have two angles and when you add them together, the angle gives you now have 90. That means that those two angles are what? Complementary angles. That tells us that this angle is complement this. This angle complement this. What that means is that if here is 40, if here is 30, here will definitely be what? 60. Because here is 30, here will be what? 60. This angle will complete this one so that the total angle will become what? Triangle. The total angle in the triangle will be what? 180 degrees. Please take note. So you can now see that this is a right angle triangle. Now supposing you have a question. The question says find this side. Maybe this side and this side are given and this side is not given. You're asked to find this side, or you're asked to find this side, or you're asked to find this side. But any side you're asked to find, the examiner must have given you the one other side or two of the angles. The examiner must have given you an angle and a side to enable you find the remaining side. So, but the most important thing is that whether you're looking for the side or the angle, you must think of what? Three ratios. It is called trigonometry because you will always be dealing with sine, cosine, and tangent. The three ratios are what? The sine, cosine, and tangent. So, knowing that, it will help you. Another thing you can do to a right angle triangle, apart from the application of sine, cosine, and tangent, is what? You're applying Pythagoras theorem. The Pythagoras theorem can be applied here to get either of the side, but you cannot use Pythagoras to get an angle. So that is the deficiency of Pythagoras theorem. But you can use a sine, cosine, and tangent to get angle as well as to get what? The sides. So let's go deep into. So let's discuss, remind ourselves what sine is, what cosine, and what tangent is. Now you know that the sine of any angle is always equal to, if I say sine theta is always equal to opposite all over what? Hypotenuse. Opposite all over hypotenuse. Cos of any angle is always equal to adjacent all over what? Hypotenuse. Tangent of any angle, let's say tan theta, is always equal to opposite all over what? Adjacent. Now, this tan is also defined as sine theta all over what? Cos. So, you can now see that tan of any angle can also be expressed in terms of sine and cos, and also opposite all over what? Adjacent. This will represent the definition of what? The tangent of any angle. How about the secant? Secant is also called sec. It's represented as sec. So we can say sec theta is equal to 1 all over what? Cos theta. Cosec theta is equal to 1 all over sine theta. Cot theta is also 1 all over tan theta. So when we say secant, we are referring to the reciprocal of what? Cos. When we say cosec, we are referring to the reciprocal of what? Sine. When we say cotangent, we are referring to the reciprocal of what? The tan. That's 1 all over what? Tan. So very important. So let's quickly take examples. So for you to have understanding on how to use trig ratios or the trigonometric ratios to solve problems of triangle, let's take care of the following questions. Now the question before us says, given sin theta equal to 4 all over 5, find cos theta minus sin theta, b cot theta minus tan theta. Now C, show that sin square theta plus cos square theta is equal to 1. Now solution. For you to answer this, you must always remember that, so because it is sine, it means it has to be applied to what? A triangle, right angle triangle. So I would then say, consider a right angle triangle ABC. Supposing we have a right angle triangle ABC. I will draw the right angle triangle ABC. Right angle triangle ABC. Now, they've told us that sine theta is equal to 4 all over 5. Remember, we define what sine is. We say sine is of any angle is opposite all over what? Hypotenuse. That's what we define. We say sine is defined as opposite all over hypotenuse. It means that the numerator is opposite, the denominator is hypotenuse. Opposite all over hypotenuse. What this means is that 4 is the opposite, 5 is the hypotenuse. So we have to go back to the triangle. Now, depending on where you choose to place your theta, I may decide to put my theta here or here. If I place my theta here, it doesn't matter place. Even if you decide to place the theta here, but you cannot place it here because this angle is already known as 90 degrees. Theta tells you that the angle is not known. So when we say theta, the theta can be placed here, you can place it here. But if you are placing it here, know that this 4 represents the opposite of your theta. If you place it here, this will be where the 4 will be. But if you place it here, the 4 will be written here. Because 4 here represents opposite. So if I place it here, this will be my 4, while the 5 here will be what? Written here. Because 5 is what? The hypotenuse. So you can see this is a right angle because the opening statement is that trigonometry is applied to right angle triangles. The trigonometry, the one that has to do with sine, cosine theta, cos theta, tan theta, is applied to what? A right angle triangle. And before my question, sine was used. That's why I have to think of what? A right angle triangle. So if this is a right angle triangle, we said what would then be the side the side AC? The AC is the side that faces 1 theta. Remember, I name my triangle ABC. You may decide to name your triangle PQR. It doesn't matter. But what is important is that wherever you place your theta, the side that faces that angle, the side that faces that angle will be what? 4. Of course, the hypotenuse is always the longest side. So this has to be what? 5. Now, having done this, let's see if we can get the remaining side. Why am I interested in knowing the remaining side? Because I know that from the question, I have seen tan, I've even seen cosine. Remember that cosine is adjacent. Now, this angle theta you need to have the adjacent of that angle. So we need to know this side. Now, for us to know that side from Pythagoras, we can say AB square is equal to AC square plus BC square. Remember that Pythagoras says that the square of the hypotenuse of a triangle, of a right angle triangle, must be equal to the sum of the square of the two opposite sides. So this is the hypotenuse, the square is AB square, equal to the square of this side, which is AC square, plus the square of this side, which is BC square. Remember, this side is known, this side is known. I want to get this side. So I will make this side the shortcut of the formula. That means BC square will be equal to AB square minus AC square. Knowing too well that the AC square has to be transferred. If it moves to the other side of the equation, it will become, the sign will change. Remember, here is positive, the sign will change to what? Minus. So we will now say that BC square is equal to, what is the value of AB? AB is 5. That will be 5 square. Minus, what is the value of AC? Is 4. It has to be 4 what? Square. And this is equal to 5 square will give you what? 25. Minus 4 square will give you what? 16. 25 minus 16, of course that will be 9. So you have BC square equal to 9. So that BC will be equal to the square root of what? 9. And the square root of 9, you know, will be what? 3. That means this part is 3. This side is 3. BC is 3. So if BC is 3, you now begin to answer the question. The first question says A cos theta minus sin theta. So question 1, we are asked to find cos theta minus sin theta. For us to get that, it means that this is more or less a formula. Sin theta is known already as 4 all over 5, but cos theta is not known. So we will say that cos theta is equal to, what is the definition of cos theta? We say cos theta is defined as what? Adjacent all over hypotenuse. Cos theta is adjacent all over hypotenuse, therefore it has to be what? 3 all over what? 5, because this is the adjacent. Now from the formula says cos theta minus sin theta. So what do? I substitute. Cos theta will be what? 3 all over 5. Now minus sin theta is was given as 4 all over 5. Now from this, if you look for the LCM will be 5. That's the lowest common multiple. Then 5 into itself, that's to say 5 divided by this 5, that is 1. 1 times 3, that will be 3 minus 5 into here will be 1 times this, that will give us what? That will give us 4. 3 minus 4, that will give us minus 1 all over 5. That means cos theta minus sin theta is equal to minus 1 all over 5. That will be the final answer. Minus 1 all over 5. That's the value of cos theta minus sin theta. Now that's the first question. Let's look at the second question. The second question says, let's look at the second question. The second question is cot theta minus tan theta. Cot theta minus tan theta. Now we need to find out what cot theta is. You know that cot theta will be equal to 1 all over tan theta. Cot theta will be equal to 1 all over tan theta. What is the tan theta itself? From the diagram, tan theta will be 4 all over what? 3. That's opposite all over what? Adjacent. Now, if that is the case, we can now say cot theta will be equal to 1 all over 4 all over 3, and that is 3 all over 4. Now, we will now say that cot theta minus tan theta is equal to, this is a formula. Now, what is the value of cot theta? Cot theta is 3 all over 4. Minus, what is the value of tan theta? Tan theta is 4 all over 3. 4 all over 3. You look for the LCM. The LCM will be what? 4 times 3 will be 12. That will be 12. 4 into 12. That's to say 12 divided by 4. That of course will be what? 3. 3 times this will give you what? 9. You break down your minus sign. 3 into this, you know, is 4. 4 times this will be what? 16. You now say 9 minus 16. 9 minus 16 will give you minus 7 all over 12. So the answer will be minus 7 all over 12. That will be the final answer. You cannot say, therefore, cot theta minus tan theta is equal to minus 7 all over 12. That will be the final answer. The third question says, you should show that sin square theta plus cos square theta is equal to 1. Now, from this question, from the diagram or from the question given, we were asked to show that sin square theta plus cos square theta, the value will be equal to 1, or the answer will be equal to 1. So how do we do that? Again, sin theta, the value of sin theta was given as what? 4 all over 5, and because the formula says square, we're going to square it. Then plus cos square theta. What is the value of cos? Cos is adjacent all over hypotenuse. We saw that to be what? 3 all over what? 5. Because this is squared, we have to square this. This will give us 4 times 4, of course that will be 16 all over 25. Plus, this times this will give us what? 9. 3 times 3, 9 all over what? 25. We look for the LCM. The LCM will be what? 25. 25 into itself, it will be 1. 1 times 16, that will be what? 16. Plus, 25 into itself, that will be 1. 1 times 9 will give us 9. What we now have will be 25 all over what? 25. 25 upon 25, that will be 1. Hence, we have established that sin square theta plus cos square theta is equal to 1. That's the final answer to that. Let's take another example. Now, before us we have a question that says find the value of theta in the following. A, cos theta equal to sin 3 theta. B, sin 5t equal to cos 5t. Solution. Now I want you to get one thing straight, that if we are given cos theta equal to sin 3 theta, the question is find the value of what theta. It will be difficult for us to have that correct if we do not try to have the same trig ratios on either side of the equation. It means that it's either we remove sine from the right hand side and we have cos there, or we remove cos from the left hand side and we have sine there. So what we need to do is to think of a way we can remove cos from the left hand side and replace with sine, or you remove sine from the right hand side and you replace with cos, so that the trig ratio on both sides must be the same. And once they are the same, you can cancel each other. You can cancel them out and you'll be left with what? The theta. Now, for you to achieve that, you remember what I told you earlier about what? Complementary angles. I told you earlier that when you have a right angle triangle, for instance, if this is a right angle triangle, and we say this is a triangle A, B, C, remember we said here is 90 degrees, and we said here can be what? Here can be theta, and this can be what? Alpha. Here can be theta, the other side can be what? Alpha. It doesn't matter where it is. But what is important is that this angle theta and this angle alpha are complementary angles. Because they are complementary angles, it means theta plus alpha, that will be what? 90 degrees. If theta plus alpha is equal to 90 degrees, it shows that theta can be equal to 90 minus alpha. It also agrees that alpha is equal to 90 minus theta. It means that if you know this angle, you can say 90 minus that value, it will give you this. If here is 30, 90 minus 30, here will be 160. Now, what is important to us with this, as this will help us solve this, is for you to remember that the sine of any angle, these two angles, theta and alpha, when you look for the sine of theta, that must be equal to the cosine of what? Alpha. Please take note, the sine of any angle must be equal to the cosine of its complement. That's to say, if I look for the sine of what? Alpha, the answer must be equal to what? The cosine of what? Theta. The sine of any angle must be equal to the cosine of its complement. The cosine of any angle must be equal to what? The sine of its complement. Therefore, it means that even cos theta, if I say cos theta will be the same as sine alpha. Cos alpha will be the same thing as sine theta. So, once you get, for example, we say here is 30, and we said, of course, the complement of 30 will be what? 60. The complement of 30 will be 60. We are saying that sin 30 will be equal to cos 60. We are saying that cos 30 will be the same thing as sin 60. We are saying that cos 30 will be the same thing as sin 60. That's what we are saying. So you have to apply that here. If you apply that here, it means that you can say cos theta, this cos theta will be the same thing as, you ask yourself, what is the complement of theta? Supposing here is now theta as it is now. Here is theta. What will this other angle be? This other angle will be equal to 90 minus theta. That means the complement of theta is 90 minus theta. We are saying cos theta. Cos theta, based on what I have told you earlier here, must be equal to what? Sine 90 minus theta. Because this other angle is 90 minus theta. Because if you sum this plus this will be equal to 90. Then if you make this the subject of the formula, it is equal to 90 minus theta. We even saw it here. So it means that cos theta is equal to sine 90 minus theta. With this, you can substitute here. So if I substitute, you know that this will, instead of writing cos theta, I will replace it with sine 90 minus theta, and that will be equal to sine 3 theta. Once you do that, sine is at the left hand side, sine is at the right hand side. The sine can cancel. You will have 90 minus theta equal to what? 3 theta. Now you make theta the subject of the formula. That will be 90. This 90, of course, this you have 90 left at the left hand side. That will be equal to 3 theta this theta goes to the other side, be plus theta. So that you have 90 equal to 4 theta. So that theta itself will be 90 all over 4. And that will be 22.5 if you divide that. You see, now while you're doing, somebody, as we said cos theta is equal to this. Another person might decide not to say cos theta. You may decide to say, take it from sine. Now, sine 3 theta. What is the complementary angle of what? 3 theta. Supposing I come here and I say that this angle is 3 theta. What will be the complementary? It will be 90 minus 3 theta. It means this angle is 90 minus 3 theta. So now, if sine theta, 3 theta, is equal to cosine, because we said the sine of any angle must be equal to the cosine of its complement. In this case, the angle is 3 theta. The complement is 90 minus 3 theta. So that this is cos 90 minus 3 theta. Now, at this point, you can now substitute. I'm trying to show you another way you can do it. If you don't go this way by substituting cos, you may decide to substitute what? Sine. If I substitute sine here, it becomes cos theta equal to, instead of sine 3 theta, I'll be writing this. That will be what? Cos 90 minus 3 theta. And of course, cos will cancel itself. This will be theta equal to 90 minus 3 theta. You try to make theta the subject of the formula. This will become theta plus 3 theta equal to what? 90. This is 4 theta equal to what? 90. Theta itself will be 90 all over 4. And the answer is 22.5. You see, it's the same. The main idea is that you want to ensure that the trig ratio at both sides must be what? Equal. The trig ratio at both sides must be equal. That's the main thing. Now let's quickly take the second one. The second question says sine 5t is equal to cos 5t. Again, the same thing. It's either you make everything sine, both at the left hand side and the right hand side sine, or you make at both sides what? Cos. Now I want to make both sides to be cos. If I want to do so, I will not say sine 5t will be equal to. Now ask yourself, the angle in this case is 5t. What is its complement? Its complement is 90 minus 5t. So I will have now the cosine of that 90 minus 5t. That will be cos 90 minus 5t. So the complement of the angle 5t is 90 minus 5t. Now the sine of the angle 5t has to be equal to the cosine of the complement, which is 90 minus 5t. And so if I substitute this here, I can say that instead of sine 5t, I can write this. That is cos 90 minus 5t equal to cos 5t. At this point, the cos will cancel so that it becomes 90 minus 5t equal to what? 5t. You make t the subject of the formula. That will be 90 equal to 5t. Inviting this to the other side, that will be what? 5t. Remember, as this 5t minus 5t crosses the quality sign to the other side, it becomes plus 5t. So you now have 90 equal to 10t. And you take t, make t the subject of the formula. That will be 9 all over what? 90 all over what? 10. And that is equal to 9 degrees. So you can see that the angle t is equal to what? 9 degrees. The first question is theta. The first question has theta. The second question has what? T. So at this point, I want to believe you have understanding of the two questions we have taken, and also an understanding of the basic idea of what trigonometric expression. So if you have any complaint, if you have any question, please don't fail to go to the comment section and drop your comment. I will respond to all of them. Again, please subscribe to this channel, turn on your notification bell so that once new videos are made, you'll be first to be notified. Don't fail to like the video and share. For if you are an old subscriber, we are very grateful. We thank you very much, and you are welcome.